like, I'm sure it's pretty much the same thing. Yeah, rigid body kinetics looks similar. Let's use our imagination. Why don't you do this question yourself? I will double check. Test speak 65. Let's do it. So the question says, and now in an exam setting, if such kind of a question arrives, you have to be clear about the interpretation of the question. Okay. So if you look at the question, hi Ghazal, if you look at the question, number one, what is happening to the center of mass? Well, when somebody is pulling 100 Newton load, this whole thing also goes up. I never fixed the center. I have not fixed the center with a pin to the whiteboard. I never said that. So as you are pulling, this whole thing also flies up in the air. If you lose this bit, then the question will be wrong. So what you will say is that you definitely have AG in the Y direction. What about alpha? Oh yeah, I think we will have an alpha. Somebody is putting a load of 100 Newton, constant load. This thing will accelerate. Angular acceleration. Yes.
Can you repeat the first sentence that you said?
So for example, if for example, I fix it to a wall,
there won't be AGY.
Of course not. This fellow will keep on rotating, but it cannot fly into the air. But this one, I never told you that it is fixed to the wall. It is flying into the air. Okay, gentlemen, finish the question. The question says that we have to start from the rest. So what is your way out? Number one, you have to write the equation and the free body diagrams. So this is my free body diagram. How many students agree with me? Let me make a nice little beautiful free body diagram. These are my loads. Boom, boom, boom. It is right now I'm making the free body diagram. So hang on. This is your T. T means applied force 100 Newton in your free body diagram. Then Bahadur asked whether this is a kinetic diagram. No, it's not. So I will just for now focus on the forces. This is the weight that is acting. And nice and beautiful. This is my W. And what about T? There is a T, right? And what is that T? This is a T. So the question says that you have to find the T because we have a rope here. Last but not least, as one of the students said, what about the kinetic diagram? So you can make a separate kinetic diagram. Personally, I would love to have the kinetic diagram on the same diagram as the free body with different colors. But just so that you are clear that in general, these diagrams are different. So you have A, G, and you have alpha in this direction. Hang on, I think I made a mistake. I'm sorry. This is wrong. I will correct myself. Just bear with me. Mistake. Come on, come on, come on. Come on. Now I remember there are mistakes here. So I will have to use a razor. You can correct yourself if you understood the mistake. Okay, so what is the mistake? The T is, I think, on the outer one, outer periphery. Not sure why I am doing this. So, okay, now it's clear to our students. Now finish the question. Do it. Free body diagram, you have it now. So do it yourself. Do the equation of Newton's or whatever and just give me the answer. Okay. And this is my T. Okay, and last but not least, there is alpha that I will put on this one. So I have alpha. Okay, the right one is the kinetics diagram. The left one is the free body diagram. If you want to put alpha and AG with different colors on the free body diagram, then I will not object. In fact, I prefer that. Okay, so let me do it. Summation of moment about the center of mass G is equal to I G alpha. Now quickly answer this question. Is this a pure rotation problem, pure translation problem, or general plane motion? General plane motion, right? We can convert, if I had told you that the center is fixed to the center, it's just rotating, then it would have been a pure rotation problem. Nice comment. And now just finish the question by doing, hang on for a second. How do we do it? So clockwise alpha is positive in my situation. So I will write clockwise is positive. Why? Because I always decide the positive or negative by looking at the right hand side, right? Alpha is clockwise for me, my intuitive feel. So now I will have a 100 multiplied by, let me change the color, it's not even visible, come on. 0.2 meter, right? Correct? I think so. Minus, we have T multiplied by 0.5, right? I hope it is correct. And this is equal to Ig alpha. What is Ig? Ig is equal to mass multiplied by radius of gyration square multiplied by alpha. What is radius of gyration? But what is the physical meaning? It is a hypothetical construct that we have created for our own benefit. Acha. Finish the question, then I think we have everything. So yeah. So I think from here I will get alpha, right? I think so. Give me the value of alpha. Yeah, question is finished. That's bizarre. Small question. Mass is 8 kilogram, kg is 0.35 meter, alpha is unknown. Oh, T is also unknown. I'm sorry. It's not over, gentlemen. So let's do another equation, I suppose. Summation of forces in the y direction is equal to MAGY. So that will be plus 100 Newton plus the tension is upward. By tension, I think you understand what I mean. Okay. Minus 78.5. What is 78.5? The weight, right? Thank you. Is equal to MAGY. Oh, wow. This problem is really now confusing because now I have three unknowns: tension, alpha, and AG. Oh, wow.
What isn't AG is equal to 0.2 times alpha?
AG is 0.2 times.
Alpha.
Got it. I understand the question, but I will tell you it's not. AG cannot be equal to. AG cannot be equal to. He's right. I think. Sorry. AG's are also right. If I'm pulling it upward, then that is R alpha. He's right. Yes, AG is R alpha. Very good remark. Very quick response. Good. Yes, he is right. I was thinking about expanding the big formula and reaching to the conclusion, but he immediately answered. Well, anyways, but I will go through the complete process actually. I don't want to. This is my equation number 1, 2, and third equation that one of the students has referred to. I will try to write that here. AG equal to अच्छा एक मिनट, 1 minute, let me answer his question. Sorry, Ahmed, you said, is it equal to alpha multiplied by R1 or R2?
0.2, which is R2.
Nahin,
Is it R1?
it's R1. That's why I was just waiting. I will explain why. Look, when you are trying to pull this up, this fellow will wrap around this, right? So technically you will have a no slip boundary condition at point C. So you need to use the R2, not R1. That's why I would prefer that all of you follow the set procedure. So go through the complete drill. AG equal to AC plus omega cross R G with respect to C. Now, if you have decided that no, I want to take this point as you are trying to imply, then go through the complete drill. I'm sure you will get more component or whatever, some different answer. Plus alpha cross, I think now you already know, so I'm just plus 0 plus 0. Now, what is AC? AC, because of the no slip condition, is 0. Right, Razan and Mitch, and your name is Durga, right? Durga, sorry. Okay, Durga, look, we have no slip condition that is happening at point C, right? Because the whole thing is going up and it is wrapping around the rope. So look at the point C. The point C is the no slip condition. At point C, you do not have any velocity, and at point C, you do not have any tangential acceleration. That's why for tangential acceleration, I'm about to put a 0. So remember that I am about to put for tangential acceleration a 0. Anyway, so now I will have the value of AG. Right. AG is equal to alpha multiplied by R1 in the upward direction, and I will actually remove the arrow. Okay. Now please understand that when I say AG equal to AC, do not put the whole AC as 0, because do you remember we did this problem when something is rolling? Then I used to ask you at the point of contact, the no slip, what is the acceleration? So you used to prove that there is always a normal acceleration that is pointing upward. You see, so remember that even here, technically your AC is not 0, but the fact that you are only concerned about which acceleration, you're concerned about how much it flies up in the air, the AG. So that's why I looked at this expression and I said, you know what, AC will have a normal component, but it definitely doesn't have a tangential component. That's why I just said, for my case, AG comes out to be only alpha cross R. For students who are saying, what about the omega square R? Don't worry, starting from rest is also given in the question. So in any case, even I had told you that omega is non-zero, still in that direction, the omega square R will not give you anything. For you, the AG is just going upward. It is only alpha cross R.
So we only consider the tangential component of AC. Sorry. Yeah,
No, alpha cross R, it's the same.
What about the omega?
That's why I'm telling you, omega square R will only give you a normal component. For me, when this fellow is going up, for me, it's only the alpha cross R. It's the midterm exam 1 problem. You remember in your midterm exam 1 problem, the fellow is going towards right or left. And I used to ask you, give me the acceleration of the center of mass. Yeah. Then all of you used to find, there were some students who quickly used to write alpha R. Why? Because the omega square R is giving you a normal component at the no slip point. Anyways, I hope you have understood this. Okay, give me the answer. So I will have AG is equal to alpha R, and for students who are still AG is alpha R, but I will also try to answer your question like this, Usman, that alpha minus K multiplied by R1 negative I. Did you get me? Huh? So if now you multiply this, you will get alpha R1 J. Very good. You got it right. Okay. Give me the answer, by the way. Then you also ask me the question. I am coming to your desk. 1 minute. 1, 2, and Ahmed, you agree, right? Give me the answers. Because when somebody is putting a load upward, I have this intuitive feel that the object will have alpha. If any alpha, it has to be clockwise. I'm pulling it upward with 100 Newton. Alpha should be clockwise, and I always want to decide the direction clockwise as positive or not by looking at the right hand side. So Ig alpha for me is clockwise, is positive. I went for that.
As the coordinate system, the right.
Doesn't matter. I never thought about anything here. The AG is handled separately. I handled AG completely separately. Give me the answer, gentlemen. Acha, this is clear. Dami, do you want me to revise? I can. Don't hesitate. Should I revise this? Fine. Okay. Nobody's giving me answers, so I will.
29.9.
You did try.
T is equal to 6.24 kilogram. Alpha is equal to 12.68.
Okay, alpha is equal to. Let me write it down. Alpha is equal to. You said 12.68. Okay, I do not have answers from my previous class, but I think it will be a good reference if I teach this course again. Okay, and AG?
6.24.
Well, the answers seem reasonable if you ask me. I don't know.
T is equal to 29.9.
29.19. 92?
No, Newton.
Newton, okay. Okay, gentlemen, the answer seems correct. Acha, one last thing. There are students, and by the way, these answers you have to double check. These are not in my notes. Acha, one last comment. This question could have been handled in another way. Your task, I will not be doing anything till 11:01. You have 5 minutes. Do this problem by summation of moments about the point C. And for those of you who have missed the class, it's an excellent opportunity to catch up. Do this problem by summation of moments about point C. Do it. So this is the second method. And just to give you a hint, it will definitely challenge your imagination a little bit. So first write summation MC is equal to which IC alpha, then equal to IG alpha plus another term, that is MAG multiplied by D. Good. Do it.
There is a D as well in that.
D is the distance. D is the distance. The distance between where MAG is acting and the points.
R1, right?
D
is R1, right? In this question.
D should be R1 now, Usman. And R1 value is 0.5, right?
Yeah.
Good. Very good. So just to involve everything, Ghazal, you also do it. Summation M subscript C is equal to IC alpha. Write it down. Then do it equal to IG alpha plus MAGD, and do this whole problem. I have given time. Not sure whether everyone is writing it. So now I will do it for you. So summation of moment about C is equal to IC alpha and which is equal to I G alpha plus M A G D. Now just remember one thing, as far as I can understand, there is no alpha that is zero in both the equations, because it's not a pure translation problem. You in any case have an alpha, so there is no alpha that is going zero. Now you focus on this second one, and just finish the question. It will become 100 into, what is the summation of moment about point C? It will be 0.5 plus 0.2, right? 0.2 plus 0.5. Tell me if I'm wrong. And it will be 0.5. Where is my pointer? 0.5 plus 0.2. Why did I take the clockwise as positive? Because I'm looking at the right hand side. That's why clockwise is positive. What is the weight? Minus 8 kilograms multiplied by 9.81 multiplied by, what is the distance between the center of mass and the point C? 0.5, right? I think Bahadur said 0.5, yes. 0.5 meter, then this is Newton. Then this, again, this is a very good habit that you handle the units as it is. Then this whole thing,
Why it's negative?
yeah, what? Weight? Because my point is that the weight is acting downward now, and the point C is, this is point C, this is the weight that is acting.
This is anti-clockwise is negative.
Huh.
That's why.
No, but hang on. I am saying anti-clockwise as negative, not out of just I decided, because for me the alpha clockwise is positive in this problem. It looks to me. That's why for me I alpha terms are clockwise positive sitting on the right hand side. I have to follow that. Clockwise is positive. Acha. Finish. Let me finish it. So is equal to IG alpha. Now use the imagination. What is IG? It was MR square, right? 8. No, sorry, MK square. I apologize. M. What is K? Point. Let me double check that the screen is shared. Okay. K value was 0.45. 0.35.
Yeah, 3.5.
Then we have alpha. Yes, Mirch.
For both 0.5 and 0.2.
Because if you look at the distance of 100 Newton from the point C, you have a big distance, which is 0.5 plus 0.2. Acha. Then I have MAG. What is M? 8. What is A? Good. Very good. He's right, by the way. Good remark. Okay. D. What is D? 0.5. 0.5. 0.5. So, for example, this is MAG.
Yeah, distance between G and C. Yeah.
This is MAG, and MAG multiplied by D. Clockwise is positive. Boom. Okay. Oh, come on. I'm not sure if anyone is volunteering to get the alpha, but I think you should get 12.68. I will just write down the answer. If it doesn't come out like this, then there is something wrong. I don't know. Life is beautiful again. AG is alpha R1. I'm just writing here so that students don't get confused. Now there are students who are saying, what about the tension? Well, do the same summation of forces in the y direction and get tension. Are you getting my point? You can do it. You just copy paste from the previous slide. Hasong is your name, right? Did I pronounce it correctly? Hasong. So are you following, right? Everything is fine? Okay. So remember, in an exam setting, 80% of the problem that happens is that students are doing summation of moments. They just forget the MAG multiplied by. It's a problem that 90% students do. Something to think about. If you are doing the summation of moments about the center of mass, life is beautiful. The moment you are doing the summation of moments about another point, this stupid MAG thing pops up because you have to multiply MAG with the B. Very easy to forget. But if I take the same system and pin it to the wall and it cannot fly, then I won't have the MAG. Why? Because it's not flying into the air. So MAG multiplied by D pretty much will give me a zero value. So that's why for a pure pure rotation, life is beautiful. Pure translation and general 2D plane motion, they become complicated because MAG wants to appear. Hanji. That's fine. Either that is wrong or here there is something wrong, but the equations are right.
10.3, right? 10.3.
Kitna?
I got
10.3. Oh, it's okay. So 10.3. 1 minute. Let me correct this. This is 10.3.
All of the other answers must also be.
It's okay. Relax. Answers are not that important right now. 10.3. So it's okay. Students can themselves double check. I will put 10.3 here. Relax. 10.3. And you can also just, I'm putting a star here, double check yourself. It's not my. Okay, gentlemen. On that note, I will proceed. Do you have any questions for me today? Should I proceed? Okay. Okay, I will try again. Okay. 6, 5, 4, 3, 2, 1. Please bear with me. Okay, let's see the next picture. Okay, so let me see the next picture. Did I? Let me pause the recording. I think I will have to connect the flash again. So I think you have to bear with me then. Okay. Okay, yeah, this one. Okay, I'm not gonna make this. You can all see this, right? Oh, come on. No. Don't look at it. I have to copy this. I want to ask a question. Copy. If I show you the answer, then it will kill the purpose. So let me. Oh, come on. So hey, 1 minute. Let me remove the options. Good. So answer this quickly. Both of them, you can see somebody is putting a load to the right. So forget about these yellow arrows. You have to tell me whether the ball rolls clockwise or anti-clockwise. Okay, so think about it. I will in the meanwhile write the options. This is 1. This is 2. And this is 3. And this is 3. And the last one is 4. There is an option of fly as well, by the way. I'm not sure where it is. Is it flying? So I will just remove this. Tell me, this one goes clockwise or anti-clockwise, and you also tell me the right one goes clockwise or anti-clockwise.
First one definitely goes.
Rolls to right?
Yeah.
Okay, let me click the answer as Ahmed said. Rolls to right is the answer. Everyone agrees?
Yes.
What about the second one? Okay, I am putting a load here.
What is smaller? Is that friction?
Yeah, that's friction.
Yeah, but why is it towards?
Well, I did explain this. Friction is towards right. I was rolling the board marker and trying to explain him a couple of days back. Friction is towards, I told you, it's a complicated problem. Can we pass this question for a few seconds? I will come back to this.
Second one also rolls right,
But
in an opposite direction. Like what I'm trying to say is that the ball goes to the right, but it turns this way. So
no, actually, it's a good that everyone is trying. So let me say that it rolls to the right, and it still goes clockwise. Actually, that's just bizarre. But anyways, that's how life is. Now, what you have to understand is, you can actually think it like this. You have this thread rolled over this fellow. So you can try it. Pull it like this, it will roll towards you. Pull it from here, it will again roll towards you. You pull it from here, it still rolls towards you. What we get confused is, Mitch, if we suddenly pull it, then we tend to feel that this thing will go opposite and will probably slide away from us. We are not getting into that. We are just saying somebody's pulling, it will still go towards right. Now, the only thing that confuses you is how on earth can both go towards right and both of them are going clockwise? Well, the answer is that in this particular case, look at the first case. There is a greater torque about this point, let's say, or there is a greater moment that this fellow is providing, if you want to talk about this. Whereas for the case on the right, probably that magnitude of moment is not being applied. So probably it will roll slowly towards right. Either way, both of them are going towards right. A classical question that many of students get confused. Now, let's look at the other options. Rolls to the left, definitely not. And the last one is, do they fly? No, they don't fly. So the answer is rolls to the right. As for your question about friction, what I'm trying to tell you is that we did talk about, if you have a board marker, it depends on how it is slipping and in which direction it is going. That's why the direction of friction has to be assumed in that particular way. Now, in a regular problem where the object is going like this, we many a times take the friction towards right, but it actually depends on the actual dynamics. You are not getting this. So one case is this. Another case is I do this and it rolls towards right. One case is I slip it. During slipping, it goes there, but it is rolling towards like this. In both these scenarios, the direction of F in the contact will be opposite. In one direction, in one it may be towards right, in the other it may be towards left. It's a complicated problem. Hanji.
Second wheel, we were to take the T force and drop it below the friction force.
Right, that's another thing.
Then it should turn the other way, right?
But we cannot drop it below friction force because below this it is a ground, right? But you are getting my point. At the end of the day, the objects, when we talk about instantaneous center, actually, I have not covered that part. But let's say there is no slipping. Let's say there is no slipping. Okay. So if there is no slipping, this is the point of contact. The force is towards right. The torque is, you can do the summation of moment about the point of contact. So it will rotate clockwise. It's just that when you see the moment arm, everyone focus here. Look, if this is your point of contact, what is the moment arm? This big thing is your moment arm. So it rotates very nicely. Focus here. Focus here. What is the moment arm? This little distance. Either way, it will go clockwise. It's very tempting to think that one of them will go opposite. But what you are suggesting is something that our problem doesn't cover, because our problem is there is a ground beneath.
What is the thing in the middle? Is that a hollow part? What is that? Why is it
Hollow, there is another protein around which I have wrapped a thread and I am pulling from that portion.
So within, if we have a thread inside in a radius and then we pull it
Huh.
like that, the outside part will rotate the opposite way. Is that what you're trying to say?
No, both of them are
Because
rotating.
if you pull it, let's say like this, it's supposed to turn.
No, that's what I'm trying to
But
say.
yeah, but because we're trying to turn it inside the hollow part, That's why.
One minute. If your question is why did you make this center portion, I will answer this. You see, there is a force that I'm applying here, right? Here. How am I even applying a force here? I need some physical thing to hold. So technically, I have wrapped thread here on this protein. I have wrapped thread, and I'm holding a piece of thread and I'm pulling it. But the whole object is solid.
No, my point is that the reason why this is the case is because we have that part, right?
No, even if we don't have that part, and let's say I have some physical thing from which I can pull this, even then it will go clockwise. So let's say I have a metal rod, but the problem is when it rolls, then the metal rod will go like this. Now, that's why I cannot have a metal rod welded to it. All I am saying is, as long as I have some way to hold that object from here and pull towards me, the object will go clockwise and it will go towards right. Yes, I will take that question. Yes, please go ahead.
I have two questions. So in first one, I understand that I'm pulling it.
So we will just proceed. Okay, gentlemen, let me please continue. Okay. Oh, come on. Again, do this problem. And by the way, this friction discussion will again come into the picture. So I will just make the question and I will try to help you with the friction direction. And probably I can send you a few videos on friction. How do I do? Let's do this. Do the problem. Okay. And hang on, everyone, take the friction towards right. Okay. Take the friction towards right. And I will explain the question later. Where is my 32.2? 32.2. No, meter per second square means feet per second square. G value is feet per second square. Acha. Yes. Both will go in the direction of the last one. Both of them will go. It does matter. They will go to the right. Oh yeah. So in that particular case, yes, we are not thinking about it. You're right. We are doing the summation of moments about that one. Okay, let me just please proceed. Okay. The question says that the acceleration of the truck is 5 feet per second square. You have to find the alpha. This problem is a little complicated. The problem statement is important. I will try to interpret it. The question says that you have to find, okay, we have to assume, that there is no slippage that is happening. I'm the one who is telling you these things, okay? Otherwise, how will you do this question, by the way? No slippage is happening. Do it. No slippage is happening in this problem. The question says that the truck is accelerating 5 feet per second square towards right. The coefficient of static and kinetic frictions are given. You have to find the angular acceleration of the drum. And I'm asking you, don't get confused. Just take the friction towards right for this drum. So let me make a free body diagram for you. Yeah, I know the friction, but right now I'm just helping you and then we can think about it. So let's say this is my friction at the point of contact. And This is my F. And the AG is towards right. But you know what? I want to make my life easy. So I will put the kinetic diagram on the free body diagram using different colors. And in an exam setting, you are allowed to do it. Because too many diagrams, they are just... So let me write AG. Call it AGX. Then I will return to my original colors and I will put W. And the next piece of the puzzle is alpha. Return back to the same colors. By the way, you are doing this problem yourself. I'm coming to your desk. Alpha. And then this point is your center of mass, which is G. After this problem, we will have a break. The radius is 3 feet. I think all of you already know. This is 3 feet. Did I mention that?
Yes, sir.
I did. Sorry. Control Z.
Is alpha 0.445?
No, it is 1.15. It is a tricky problem. I have to comment on it. It's 1.154. Okay, but the important thing is I need to see the equation that you wrote. If your equation is correct, then it's not a big thing actually. Acha. The last but not least is AG friction. What about normal force? Anyone who wants to talk about normal force? We have a normal force, no? Yeah, seems like that. Okay. Okay, double check. Normal force, weight, AG, alpha, friction. I think there is one mistake. Let's see anyone who can tell me the mistake in the kinetic diagram. The orange arrows. The truck is going towards right. So what will be the acceleration here? Any student? Right? Very good. So the AT value will be 0 or 5? 0 or 5? Nice. Because in your no slip condition, when this table is not going anywhere, then at the point of contact, the AT was 0, right? At the point of contact. You remember midterm 1 exam? But now the whole table is going towards right. So in a no slip condition, whatever the velocity of the table is, that point of contact will also have the same velocity, and the point of contact will have the same tangential acceleration. Should I repeat this, or is it clear?
What we are doing right now is against the conservation of momentum.
No. Why? Because the friction is towards right.
That was a friction. If the truck is going right,
Huh?
the more on the truck will go left because of conservation of momentum.
So the answers will come out to be negative. Very good. Let me actually see. Good. Very good. But acha. Yeah, but look at the alpha. Alpha is counterclockwise. Look, what you have to understand is no, our answers will come out to be different. We are not going anything against the law of conservation of momentum. Okay. Look, hang on. Look at like this. This is going like this. Coca-Cola can is sitting on top of it. The lower edge of the Coca-Cola can, the point of contact of it, has the same velocity as the velocity of the truck. So now technically it wants to
I understand.
so it's like a carpet I am pulling beneath your feet. So it's a little complicated. That's why it's not that intuitive for us to. Okay, anyways, let me now go over. It's a little complicated, gentlemen. So I want to do it. So now let us finish the question by doing summation of, let me do a nice pink color. Tell me if it's visible or not. Summation, visible. Summation of fx equal to m a g x, and similarly summation of moments about center of mass is equal to ig. Hassan, do it. Everyone. Yes. AD, so AD is the acceleration of the truck. T as in truck. So if the truck is accelerating towards right, then technically the cylinder is sitting on the truck. So usually when we used to say was that if there is a Coca-Cola can sitting like this, and this surface is not going anywhere, according to no slip condition. Now if I roll it towards right, Coca-Cola can will keep on going towards right. So the point of contact will have actually a zero tangential acceleration. This is the rule of no slip condition. In this particular case, just both surface is actually accelerating towards right with an acceleration of 5. So that's why the point of contact where it is touching the truck, the pink cylinder, that point of contact, in fact, you can see that orange arrow. If you go to diagram, 80. 80 is at point of contact, if there is an 80, that is the acceleration of the truck. Because if I am sitting on the truck and the truck is accelerating, then so am I because I'm sitting on the truck. Right? Huh? It's not happening. So if the truck is going with the initial acceleration of the Coca-Cola can, that's why I put 80 down there. Yes.
So you said no slip count, right? So yes, okay. But if it's no slip, that means it's about.
US, no? I think US.
The answer 0.1275.
What, alpha or AG?
Alpha.
Alpha is 1.154, Ahmed, 1.154. Hang on. Let me first answer his question and then I will answer where is the mistake. Will you use mu k or mu s? Okay, the point is, gentlemen, you will be using nothing, just the friction. So let me go step by step. Just bear with me, everyone. I need a nice orange color. Plus F, then equal to M A G X. Let me use a brown color now. Summation mg is equal to Ig alpha. Now alpha is anti-clockwise positive. If you see my drawing, so I will have m k g square alpha, and it will be f multiplied by r. Anti-clockwise is positive. Can you double check, everyone? Now I will write, assume no slippage is happening. So you will have AG equal to A truck plus AG with respect to T. Now what is the first term? I think you already know, that is 5 feet per second square. I think towards right, if I'm not wrong. And what is the next term? It is alpha multiplied by R. So I suppose it will be R alpha in the negative I direction. Can you double check for me? No? I think so. Anyways, so in this way, I will have the final answer let me use a blue color of AG. Again, this is an arrow, comes out to be whatever. So I think that's enough. Now, just put everything inside. So I will have F equal to MAGX. So I will put instead of this AGX, I will put 5 minus R alpha. And that will be my first equation. And then I have summation of moment about G is equal to IG alpha. That is my second equation. Let me use this. So this is my first equation. And this is my second equation. Can you do it now? At least give me the value of F and give me the value of AG, which is AGX in other words. AG or AGX, whatever. It's not flying in the air anyways. Give me the value of F, alpha and AG. Come on, you can do it. It's simple calculation now, nahin? Because if alpha is counterclockwise, that is a positive K, then G with respect to the T is in the positive J direction, and K cross J is negative I or not? K cross J, can you double check? K cross J? K cross J. K cross J is negative I. Yeah, correct.
Hocam, that acceleration that you said, the acceleration of G with respect to T, is when the, I don't know, the ball, or I don't know what that is, the circle. That circle's acceleration when it's inside the track, like on the track, right?
Yes, it has alpha
So
of its own.
that's why it's just alpha itself, basically.
Yeah, alpha itself. Is anyone doing it with calculator? Right. Okay, Osman is doing, so I will just wait. So positive F is equal to 5 minus R alpha. And second equation is FR is equal to mkg square alpha.
You wrote that GX equals AT plus AG with respect to T. So found that from the original.
Yeah. Of course, this big thing is your rigid body kinematics. Now you can ask me, Mitch. You can ask me, why isn't there omega cross R term? For the same reason, omega cross R will give you a J. You remember midterm exam 1, omega square R used to give you a J component. I don't care. I'm concerned about the X. What happened? Yes.
And also so AG with respect to T. So
That is hang on. Ek minute. AG with respect to T means those big terms. Remember? R alpha, omega square R, 2 omega cross V, AG with respect to T, small xyz. Those big terms constitute AG with respect to T. Yes.
I found alpha is 1.5.
Oh yeah, come on. I need to have the right answer.
Maybe it's not.
1.15, no?
Yeah.
1.15 or 1.5?
1.5.
Ah. And what about AG?
G is 2.
I have 1.538. Anyways, nothing to worry. I have to continue. So let me just write down the answers. I think you can all do it yourself. The answers I have are correct. I will just repeat. I did a summation of forces in the x direction. F is the friction towards right is equal to MAGX. Instead of AGX, I wrote AT plus AG with respect to T. Students who want to put X here and X here are completely allowed to do it. So let me in fact do it in case you are getting confused. And then I got nice and beautiful answer of AGX in terms of alpha. I substituted here. I have another equation. So I have check. This is where a student was asking about coefficient of kinetic and static friction. We will go on a break now. F less than equal to Fs max gives, what is Fs max? It is mu s n. What is the value of Fs max? What is the 30 pound force, right? And how do you do that? You multiply the 200 with 0.15, I suppose. Now, what about alpha? Alpha is 1.154 radian per second square.
I have also found 1.154.
Got it?
Yeah.
Good. Because I was worried then. I was worried that the note, because the notes I think are correct. Ag is 1.538 inch per second square. And the F value I am getting today is 9.6 pound force. Wow. So is my friction force less than the maximum static friction or not? It is, right? It is. Now, why don't you all help me with one more concept? What about the friction Fk? I'm not even sure whether it's the right term, but we will go on a break, everyone. Just give me 1 second. Mu Kn. The value will come out to be 20, right? So here's the bizarre thing that is happening. I am getting a friction force of 9.6. So let me draw a plot. I am seeing some students who definitely want to go for a break. I will go in for a break in 2 minutes. Just hang in there with me, please. I actually agree with you, but I am in the middle of the question. So just bear with me. Thank you. This is my friction force or whatever. Now 30 pound per force is somewhere here. Oh, come on. The color changes. So this is my 30 pound force. 30 pound force. And this is my 20 pound force. Agreed? Like this. Let's say this is my 20 pound force. And where are you sitting? You are sitting at 9.6. I think we are somewhere here. I'm not sure whether it's up to scale or not. And then let me continue this with a purple line and we are going for a break. Boom. Okay. The y-axis will have friction or whatever.
I remember it's not straight. It's like an explanation.
Really? The drop?
Yeah.
Why? Why the drop will
I
explain?
don't know. That's how I remember. I don't know.
Probably in some advanced classes, but I think it's a pretty straightforward that for coefficient of static friction, it offers so much force. The moment object has started to roll, it becomes mu Kn. So it drops. Right? If I'm trying to push something, it needs a huge force. The moment it starts to move, boom, mu Kn. There's a drop in the force that is required. Exactly. So, for example, if I'm trying to push it, and then it will move, right? So for
That's to
me,
exceed the-
yeah, exactly. For me, the maximum force at it, that is 30. But the moment it has started to move, immediately the friction offered by this water bottle width has dropped to 20. Now, for me, I can just put a load of 20 to this move. Yeah, there's no slippage. You're right. No, hang on. We are now confusing three different things. Slippage is different. The slippage means that the contact point will have a different velocity than the surface. It is still moving. There is no slippage, but it is still moving. So, for example, if I have this pen, just because it is rolling doesn't mean it is slipping. Now it will slip. You see, slippage is different. Just because something is rolling doesn't necessarily mean that it is slipping. It's just rolling. Do you want a 10-minute break?
Yes.
Yeah, please.
Let me pause the recording, then I will answer. 10-minute break it is. I hope everyone is fresh after the break. Let me just, I'm not gonna write anything. In fact, what I want from you is, I think you already know this couple of weeks back. I did cover this in point mass kinetics. Why don't you just write it down, have a look at it? I can start at 11:58 if you want. Take 4 minutes. Absorb this. Think about it. Should I zoom in? नहीं, बस काफी है. Yes.
I have a question about the previous example. So
Why is everyone laughing?
What on earth did you just say?
Why is everyone laughing? Okay, ask. I just smile. I'm not sure that everyone is now.
I couldn't understand too.
I'm not sure.
I don't know.
The roller that is going left or right?
No, not that one, not that one. The previous question. We have tracking system. So in that question, we don't have friction.
Yeah, exactly, because look, the whole point is that right now we are not even sure whether the drum is about to move. For example, I mean roll, is about to roll, is already rolling. What exactly is the situation of that drum? Because the truck is already accelerating, it's going, what was that? Can or whatever it is sitting there. If I find the friction force, I have got the value. Now I have found the F, I have found the F, I have found everything. Now I can sit and claim what is the mu s value, what is the mu k value. So I will find the mu s n, mu k n. Then whatever friction force I got, I will compare with that. Then it will tell me whether I am about to have that can roll, number one, whether it is very close to Fs or it is in the Fk value. It is rolling. Or third, it is still a little far from that zone of about to move. That's why we got a value of 9 or 3. Did I answer?
Yeah, so we have how many equations? We have two equations.
We have 3 equations. One is kinematic equation, Ag equal to At plus that vector. Then we have one equation with the summation of forces in the x direction. And then we have one equation for the summation of moments about the center of mass.
Yeah.
So technically we have 3 equations. But I wrote only 2 equations because I incorporated the third equation in the first equation.
Okay. So we found the alpha and Ag value.
Yeah, and
therefore
F.
we can find the F.
Ag, alpha, and F. 3 things that we found. Okay. Again, I'm not sure why everyone was smiling, but anyways, as long as the class is enjoying. Okay. Can we please focus here? Oh, come on, everyone. We have to proceed. Rashid Khan, Usman, quickly go over it. Your Tashish Khan, right? What is your name? Char. Sorry. Okay. See this. Gentlemen, in 2 minutes, I am starting the question. So we have the momentum. The translation momentum is mass multiplied by velocity. The rate of change of translational momentum is equal to mv dot, which is nothing more than your summation of forces in the x direction. Focus on the left side. Then we have g dot dt is, what is that? If I have g dot dt, that means impulse, right? So g dot dt is equal to mdv. We have already covered that in point mass, by the way. Then we can take the integration. Then the left side says area under the GT curve is actually nothing more than your change of momentum. The area under GT or G dot DT? I don't know. We have to think about it. Sure.
Yeah, because the integration is area under and there is G dot. And we are getting the moment, so it should actually be the force, not the.
I have to look into it. I think, okay, anyways, probably there is a typo. Okay, in the rotational, everything is easy. You replace the symbol with H. In linear momentum, you have mass multiplied by velocity. Now you have I multiplied by omega, makes sense. Then H dot G, rotation, rate of change of rotational momentum, is actually equal to the summation of moments. Again, in point mass kinetics, I talked about it. Then hg dot dt equal to ig d omega. You take the integration and you get this equal to ig delta omega. So straightforward. We can actually Google this so we don't have any confusion. Just write area under GT diagram on your mobiles. We will see whether I actually have a typo in my notes. Something to think about. Do it. It will help me, by the way. I don't have internet. What happened? No. Cannot be. Area under HT diagram. Anyways, we can proceed in the meanwhile. So let's talk about the next question. Come on. Hang on for a second. We have open with paint. So we have P is equal to, is this given to us? Find omega after 2 seconds. P, I think, is given to us. Surrender starts from rest. So I have, this thing is a gonna control X. Okay, do it. एक मिनट. Probably for now, नहीं, this ज़्यादा हो गया काम. Hang on. Okay, so W is equal to 20 pound force. That's the weight. And now I will just zoom in a little bit. Okay, remember, W is 20 pound force. Other than that, everything is fine. Do it.
The same goes for your search.
Sorry.
The same goes for your search.
Do it, you mean?
Yeah, you do it too.
Okay, I will do it. Okay, I will do it. Okay. Everyone is in a very good mood today, right? I'm not sure why.
We're all going crazy.
I don't know. Okay, there will be a limit.
The rest of the semester.
Yeah.
The load is given, or should we supposed to find it? Like that
If-
load.
No, I got the question. In fact, you know, when I was looking at the problem, I also stopped for a second. In fact, that's a good question. It can be a mistake actually, because if you have to find the moment, what's the point of P? Let me just double check. For a second I thought about it, but then I thought no. M plus P multiplied by R. You know what? It is given. It is given. So let me add one more thing. It's a good question. His question is, do we have to find the P? The answer is no. P and M are both given. Now the obvious question is, what's the point of someone giving you M as well as P? Well, what happens is that if you have a if you have a dynamical system, you can rotate the object like this, giving it a moment, right? On top of that, you can also pull using a rope, and again you are trying to move it. So technically someone is giving a moment and someone is actually pulling the rope as well. Or you can, are you getting my point? So in fact, if someone was pulling it by a rope, they could have put it in the form of a moment, that a moment is being applied. But in this particular question, someone has given you moment separately and P separately. Or you can think that someone is driving this using a motor on the back, that is your M moment, and someone is also pulling it using a rope. So you have now a P that is giving a certain kind of a moment, and there is a moment that is acting as well. Okay, you can solve the question.
One fund a big number. 131.66.
ठीक है, एक मिनट,
31.66. Omega.
Okay, I have 62.8 radians per second. Your answer for some reason is 2 times. I'm not sure why. So let's go step by step. What is the value of, no, sorry. I apologize. I looked at the wrong. Omega 2 is, you found what value?
The omega 2.
What is the answer? 130?
131.66.
1.66. It's not in my notes. So what I can do is it's not in my notes. I will do it in front of you right now, and you just tell me whether you did everything fine. So integral mg dt will be integral 0 to 2. The moment is 4 in the clockwise direction, plus the load P, I think I gave you as 10. The radius I gave you as 0.75. Then I have bracket. This value is in feet pound. Then I have dt. So if you have a dt, I will put a t here and I will use a razor and I will just remove it, because this fellow is a constant, right, in its coefficient. Now I will put a bar, right, and then I will put the limits. Ghazal is with us, right? Then we have 0 to 2, and then I have equal to, let me use a purple color or whatever. Okay, what is the Ig value? It is given to me in half. Mass is 20, 32.2, because I think it was the weight, if I remember. Multiply by radius is 0.75 square into omega 2 minus 0. Then omega 2 comes out, I don't know, whatever you told me, 133, right?
Yeah, 1+3+6.
Now, in an exam setting, everyone, in an exam setting, I will not probably tell you which method to follow. So it's entirely up to you. The same question could be done by summation of moments as well, right? Will you be able to do it yourself? Yeah, it's straightforward. So you can do a summation of moments about the center equal to I alpha. I is given to you. Moments you know, do it if you want, and you can get the value of alpha. The question says find omega after 2 seconds. So omega f equal to omega I plus alpha delta t if alpha is constant. Is it clear? No? Yes? Anyways. Okay.
Joe,
Uh-huh.
the omega after 2 seconds.
133 is what Ahmed told.
131.
What?
1+1.
Yeah, whatever. 131. I even did not care that much. 131, 133, whatever. 131 point. Okay, do it by Newton's law. No one is participating. Do it by Newton's law. Summation of moment. Do it. Summation of moment is equal to I alpha. Because in an exam setting, trust me, you will be thinking which method to follow. Do it. Find alpha. If alpha is a constant, then use omega f equal to omega I plus alpha delta. GG. No, 206 exam I grade few students. Your exam I could not grade. What is this full name? Yeah, okay, I will grade it. Everyone's paper. But on 17, 18, all the packets will be over. Before final exam, it's do it. Do this question. I'm waiting for you.
What was the relation between alpha and omega in terms of the time?
Yeah. So constant angular acceleration. You remember that Vf equal to Vi plus At. Those formulas that we studied. Constant. So just replace the V with the omega. Remember constant acceleration, constant alpha, omega f equal to omega I plus alpha.
Then it's just equal to alpha times 2. That's it. That's it.
Omega f equal to omega I. Omega is 0 plus alpha delta t. Did you get the same omega?
Yeah, obviously. It's going to be the same.
Sure, 100%. 100%.
Exactly the same.
Anyone else? Which? Did you do summation of moments? No? Do you want me to do it for you?
All we do is divide the first equation by 2, then multiply it with 2 again.
Okay, anyways, yeah, summation of moments is equal to Ig alpha. Yeah, I think you said yes. Yeah, summation, nothing too much changes actually, right? Okay, should I proceed now? So do the next question then. We have, let's say, we have enough time, by the way, so I will just switch to a whiteboard. The question says, because question says that I have 10 kilograms is the mass of this. This is my cylinder A. This is kg equal to 200 millimeter. The radius of this is 250 millimeter. The question says that I have this motor that is deriving this. Let's call this as nice and beautiful purple color. This is my motor B. The question says that if this is 3 kilogram, Ka is equal to 80 millimeter and R is equal to 100 millimeter, and the Hanji.
When you say A, you mean AB? Because you get
Ek minute, sorry. Hang on. I have to.
that's gyroscopic.
Radius of gyration. Yeah, I have to correct myself. Now I have to wait. Sorry. Yeah. Thanks for pointing out. This is A, B. Yes, it's mistaken my notes because it doesn't make any sense. So it will be. By the way, if still there is a mistake, then I will just let you know, probably KB as of now. And RB, as you rightly pointed out. And moment applied on the motor is 6 Newton meter. Yeah, thank you. Because I think I was just getting confused. This will be then MA KGA, I mean, because it's A. Okay, question says find time to get motor omega B. Find time to get motor to go to 600 RPM. So this is your final, and I suppose system starts from rest. It is given in the question. Give me the time. Okay, do it. Now, by the way, this problem is a little tricky. It's not straightforward because both of them are in contact with each other. Yes. Question.
What? Some you already said that, Jan. What else should I say, Jan?
Try. So just a quick.
Then what are you waiting for to try it too, Jan? Yeah, the news group started. We know that topic. Don't worry.
What exactly are you saying?
Nothing what I never noticed.
Do it. You know, just to motivate you, should I give you bonus points for doing this question?
What? What did you just say?
Bonus points?
Bonus points.
Yeah.
It could be good hocam.
What do you mean it would be good, Ahmet? On the contrary, it would be worse, yeah.
Okay, then join this flow now.
Hocam, is the initial angular velocity of the motor is 0?
0. Give it. Okay. Just a quick remark, because if you don't make the free body diagram, you will not be able to crack this. So let me tell you something, because both of them are in contact with each other. So hang on for a second. Number one, this is the free body diagram. If you don't draw the free body diagram, you will not be able to do it, because there is a force that is acting on this. Remember, because if you don't draw it, you will not be able to understand that there is actually a force that is acting on this cylinder or whatever. And then if you draw the second free body diagram of this for the motor, of course, if the motor is going like this has to bear a force by the cylinder in that direction. And of course, you really want to make the arrows parallel, right?
Hocam, there is one thing that I don't understand.
GG.
And that is that why do even I have to care about object A if you are just asking me to find the angular velocity of object B, which has actually generated the moment regardless of object A.
Yeah, because we have to take care of that, because at the end of the day, if I have a massive A with a huge moment of inertia and there is a small motor, of course the motor has to bear, it has to rotate that one, na? It is
I
rotating.
understand. So the total moment of inertia is going to be the not just the motors, but also the combination of both object A and object B. Am I correct?
You are actually right, but I would actually, if I have to do this question, I will do this question in another way. I will actually write the summation of moment for point B, I mean the object B separately, the equation for it separately, and the summation of moment for A for that object separately. But that F will come into both of them. So they are, you can say, coupled by that force F. They are not separated. If, for example, you put these two objects separately, that's another thing. But since you have connected them, the F will be the connection factor. So just let me write one equation for you, and then you can let me know if this is clear or not. Just write, let's say, because I don't think I will add, but anyways, for A, let us say F, let me say this is my A, this is B. So I will have F multiplied by RA multiplied by delta T, right? Because integral m dt, right, is equal to K G square M A, because integral m dt, let me write down the equation if students are getting confused. Integral of summation of moments dt, we go from T1, T2 is equal to I G delta omega, right? I'm solving this. So I will get a nice, beautiful equation. MA, we will have omega 2A. Let me use a pink color. This is my equation. One. And then similarly, I have for B, you will have, hang on, did I? Yes, I included the F, right? For B, I will have again equal to I, that is M, R square, I mean kg square, omega 2B. Give me the left hand side. Badal, give me the left hand side. Just write down. I just want to have a look. Give me the left hand side for B in the equation. For B, yeah. So for B, I have in the free body diagram, I think a moment as well. I think they did give me a moment, right? So this is the moment. Moment is anti-clockwise. So if the moment is anti-clockwise, let's say counterclockwise, because of the omega, I think is positive, then I will have positive M. That's it? No, minus F R B delta T. Why didn't I write any M here? Anyone? Because the motor is only driving this one. That's why the moment because of the motor appears here. So this gives me two equations. And there is one mistake because I cannot write the moment separately. I have to multiply this with a delta t. Why? Because you can see this equation, integral summation of moment delta t. M is a constant, so constant multiplied by delta t. Then summation of moments will also have a minus FRB. So M minus FRB is the summation of moments. Delta t, dt becomes delta t because M minus FRB is a constant. So omega b comes out to be omega b or 2b, whatever you want, comes out. In fact, here you can write, if you want, if it's not clear, M delta t minus FRB delta t is equal to M k g square delta omega. And delta omega is omega b2 minus omega 1b, which is 0. That's why here I only write omega 2b. Similarly, here you can write the same fellow, delta omega gives me omega 2a minus 0, because the big fellow is also 0 initially. Is this clear or not? No? Yes.
What about omega 2a?
We have to omega 2a. Yeah, it is not given in the question.
So we need 3.
Yeah, we need one more equation. So what will be the third equation? Anyone? Hussain is right. We need one more equation. Anyone? I don't know omega 2a. I don't know omega 2b. And I also don't know the f. So I have
A times R B is equal to omega 2b times RA.
yeah, good. Say it one more time. Omega.
Omega 2a times RB will be equal to omega 2b times RA.
No, why did you cross multiply the R? So let's go step by step. VC is equal to RC, not RC, I mean RB, multiplied by omega B. Your answer was very close but not correct. RA multiplied by omega A. So I'm not sure why did you cross multiply them, but anyways, RB omega B is equal to RA omega. Right? So Hussein's answer is, this is the third equation. Nice comment, Hussein. So all you can do is put a 2 here if you want. Okay. 2a or a2, whatever. It's entirely up to you. As long as you understand this is the final.
Why do we have to separate the A and B? Why can't we just say that the total force acting on the system is equal and the total moment is 6 Newton-meter, and this is the total moment of inertia?
We can do it. I haven't done it in my notes. We can try. So do the complete summation of moment over the whole system is equal to the moment of inertia offered by the whole system, which you are right. How would be summation of moment is equal to I alpha? But then we can write it as a whole. I'm just not sure how right now. Won't it be more complicated?
For the part alpha, we need to do the extra m times acceleration d, this kind of thing, right? For the Amit's suggestion.
Because where they are in touch with each other, shouldn't we have the same tangential acceleration at the point of contact? So you will have R1 alpha 1 or RA alpha A equal to RB alpha B. So you have different alphas. So you can try if you want. I'm just not sure. Let's say his remark is, why don't we summation of moment of the whole system is equal to I alpha. My point is the alpha for both those fellows is different. So do you want to add them separately and do it? Try it. I just did not attempt it. But if I were you, I will do it separately. But just what I want to emphasize, can you do this by summation of moments separately? Yeah, you can. So you will write summation of moment of A equal to IA alpha A. What about summation of moment for the other fellow? It is equal to IB alpha B, right? So what about our A? Our A has clockwise force acting like this. In fact, I will save my time. I can even see it here. FRA is equal to FRA is equal to m kg square. So it will be FRA equal to MA kg square multiplied by alpha A, right? I think so.
Then we get the alpha from that. No, all of that. No, we don't know F. No, we know F because F should be equal to
M. Ha, ek minute.
and
Ha.
thus we can divide it. So we can, we know all of this. We will get alpha A, and then we will get VC. From that we will get alpha B. From the that we will divide the RPM value after we convert to radian per second to that alpha to get the time.
But
We don't have to solve three equations.
ek minute. This is the, let's say, let's call this as equation whatever.
But there's no unknown. It's just one equation.
Ek minute. Let's call this as equation 1. Let's call this as equation 2. I will tell you what are the unknowns. So I am doing this problem again, right? Again, separately. So what are the unknowns? F and then alpha A and then alpha B. What is the third equation? The same. AC, the point of contact, the tangential acceleration is R alpha A and AC equal to, look at here everyone, at the point of contact, RB alpha. So if you equate them, you get, agreed. So this is my third equation. Now that you have F alpha A alpha B, we have to find omega B, right? Omega B2. So omega B2 will be omega I plus alpha delta T. What is the limitation of this equation? That the alpha has to be constant. No, constant. If it's not constant, you are not allowed to use these equations. Then you will have to perform integration. So now if you have this fellow as 0, if I remember, this is known and delta T is given to you as are we given 600 RPM. Oh, sorry. So this is 600 into RPM to radians per second is RPM to radians per second is
16 divided by R times 2P.
Yeah, you're right. I think it's pi by 180 divided by 60.
But there's R.
Okay, tell me the conversion RPM to
It's just equal to 0.01 radian per second.
really
Yeah, just
0.01.
No. The entire thing when you multiply, convert.
Just give me the conversion. RPM to radians per second. Rotation per minute.
16 divided by 2 pi 0.1. 2 pi 0.1
Like this.
times 0.1.
like
In
this
the bottom.
in the bottom. Okay. Anyways,
60. not
660.
Because it's minute.
Okay, so we have. Okay, do it themselves, and alpha is known, and you can find delta t. So I will just do a control Z. I think everyone understands this. This is known. Delta t is unknown. So we did the same question by. Question is over. So there was only this trick that you had to find the force that was acting when both of them were meshed.
Hocam ona bak bu normal.
What normal forces?
Well, they're in contact. There are normal. Those
Yeah, but
those are not.
those are not required. I don't care about them because at the end of the day, when they are rotating, it's the tangential acceleration, it's the moment, the force, the normal will go right through their centers.
So that F is actually generated from the generator of which has the M as well, right? Those F's come from that. M.
No, the motor creates the moment like moment is provided by the motor.
And that's actually the action force.
The F is the one that appears because of the fact that it is in contact with this big giant fellow. So there is a F given by that fellow that wants to rotate. The class is over, by the way. If you have any questions, just feel free to ask me. Okay, everyone.
Çalışalım yoksa sen?
So force versus time is a change of momentum. I think there was a typo. I will just correct it next time. Have a good day, gentlemen. Ladies and gentlemen, bye bye.
What time is it now, bro? 2:40, right?
Okay, let me.